What's the most used man-made material on Earth? I'll give you the answer. Concrete. This is the Concrete Logic Podcast. Have you ever stopped to think about the sidewalks, driveways, bridges, or the buildings around you? They're all made from concrete. So why don't we discuss it more? In each episode of Concrete Logic, we'll explore a unique concrete-related topic with the help of industry professionals shaping the trade's future. We'll talk with suppliers, contractors, architects, engineers, specialists, and even proponents of competing materials. We'll get their views on concrete and their visions for its future. So get ready to mix things up with Concrete Logic, where we turn the spotlight on the material that's everywhere but often overlooked. This is the Concrete Logic Podcast. And now, here's your host, Seth Tandit.
Welcome to another episode of the Concrete Logic Podcast. And today I have Rich Saichi and Dr. John Belkowitz. Rich, we can say you're with Big Town now?
Yes, it's
okay,
official.
Because last time I talked to you, it was top secret. So
it was. Now it's official. Yep, I'm with Big Town.
All right, Dr. John's with Intelligent Concrete today. Next time we talk to him, he'll be with Eddie Stone. So,
did you know that Rich is also a doctor?
Yeah, I was going to ask, should I be calling him Doc? I could go Dr. Rich and Dr. John.
No, I think one doctor in the house right now is enough.
Okay. Yeah, like I said, it's gonna be an effort today to keep these two in the corral. But we're gonna talk about we may be screwing up our water mix ratios with the new cement and fly ashes that we're using out there. So we're gonna talk a little bit about that today. Before we get started, just to remind everybody to support the podcast, there's 3 things you can do. One is when you get all the knowledge out of these 2 gentlemen today, you should share the podcast. Don't be selfish. So share it with a colleague or a coworker. The second thing you can do is go to concretelogicpodcast.com. There are a couple ways that you can reach me. There's a contact button on there, and there's a microphone in the bottom right-hand corner of the web page. So the contact button obviously will send me a nice email, or you can hit that microphone and that'll record a voice message. So it's like sending me a voicemail. And what I'm looking for you guys is a topic or guest suggestion that you want to hear on the podcast, because this is what the podcast is all about. It's about what y'all want to hear and what you want to learn. And then the last way is on the same concretelogicpodcast.com homepage. There's a donate button, and we've been getting donations lately. And if you've noticed, we got a new intro and outro to the podcast. So those donations that were given to me, I put right back into the podcast. I don't use it for anything else. It goes right back into the podcast. So the more donations we get, the better this podcast gets. That's how it works. So I appreciate everybody that's donated of recent. If you want to know who's been donating, when you look at the show notes for each episode, the folks that have donated are listed as producers of the show. So that's what that means.
Stop being cheap. Break open your checkbooks and donate. This is an amazing podcast.
Thank you. I appreciate that. Yeah. Anyhow, so Dr. John reached out and said he wanted to get Rich on here, and we want to talk about water to cement ratios and So you want to kick off?
Yeah.
You sent me this fancy abstract.
I know. We don't need a fancy abstract.
I'm an academic or something.
No. I want to write a paper on this, and, I've been putting some numbers together. And, bear in mind, my background is I have not worked in a ready mix plant since I had a full head of hair, gentlemen. I spent a long time in a ready mix. My nose, is forever damaged by all the cement dust. I've got some great war stories, but it's been a long time. I am, as I spoke with Michael Fabel this morning, a guy who is by the book. I love by the book. And some of these standards, I mean, going back, so was it 1918 with Duff Abrams' law to where we are today with Colin Lobo teaching the short course. And that's where I want to start off this discussion. Forget the abstract. I want to start off with the Colin Lobo story. Is that cool?
Yeah. He's going to be a future guest, by the way.
I know. I cannot wait for him to be a guest. Huge fan. So we're at ASTM, and it was a meeting at ASTM C618, and the subcommittee, is that what it is?
Yeah,
Subcommittee just found out that fly ash providers have been putting limestone fines in the fly ash for a period of time. That it's not going to happen. It has been happening. And this is not my interpretation. I'm just sitting in the room and I'm replaying the notes for you guys.
When was this?
Philadelphia, Rich.
Yeah, so this was June. This was 60 days ago, 90 days ago.
Oh, right. Okay. So recent.
Yeah. So this was
right.
Oh, great.
Okay, this is better for worse. This is the industry that we live in right now.
Yeah.
And the reason why I bring up Colin Lobo, because, and man, I'm getting nervous. Whitney told me not to get nervous. She said, just be yourself. And I was like, what are you talking about, Whit? And she goes, well, sometimes when you get around Rich, you get really, really nervous. So this is me. I'm straightening things out over here to make sure it's. So Colin's in the back right-hand side, maybe third row from the back, and Colin says, hold on a second. And Colin is not a man of many words. He reminds me of John Wayne. You know, he talks low, he talks slow, and he doesn't say much at all. Either that or he doesn't like me. I don't know. But anyway, Colin asked the question, hold on a second. First, you're telling me there's a certain amount of limestone fines that are going to replace my hydraulic cement. And it can change within a certain parameter. And now you're telling me that I have an unknown amount of limestone fines in my fly ash. How am I supposed to calculate my water cement ratio, my water cementitious ratio? And by the way, I'm paraphrasing. And the note taker, the secretary, whatever his name is from University Miami. Oh my gosh, he said, and I quote, why does that matter? And that is the abstract. That is me trying to say, what the fat man, without using a cuss word and trying to sound more professional.
So, but, John, let me add something to your gumbo soup there a little bit.
Please.
So now I want you to imagine, so you've just listed two materials that have limestone fines in them, okay? What would happen if I told you that in a ready-mix application, we recycle water that contains a certain amount of fines, and the specific gravity of the water is no longer 1, but it's 1.02, 1.03, 1.04, and that those fines may or may not be included back into the water that go into the concrete. Then, hang in there, let me get one more thing for the soup for you. Let's go ahead and take some of our finer sands, because in some of the markets that we're running into, the sands are getting fine, and we're blending silica sands with manufactured sands that are right up on the edge of the minus 200s. So what do you think you're looking at for fines content and calculation? So I'm just going to throw that in there just to start the discussion, because I know where we're going. But it's not just from the cementitious materials. You've got fines from other sources that may or may not be known. So
I don't
want to just limit it to those two, because there are others.
Okay, so there's a cacophony of things going on. There's a manifold of issues that we have making concrete. You know, years ago, you once told me that concrete production is more of a transport industry than anything. It happens to be that we're transporting a perishable material. I would switch it from, we've gone from a logistics industry to a risk management industry. And there are a number of materials that are going through a swing, not just the fines from our aggregate, the type of aggregate, the reactivity, but also our supplementary cementitious materials. The reason why I brought up the change in C150 and the 595 is not because I guess the fines, it's because of the major reduction or replacement of the hydraulic material in our cements, the one-to-one argument, and how that has affected the industry. And case in point, we have clients who, let's say on the East, who are not bringing cement in, who are using the Type 1Ls, who've had to increase their powder content by 10 to 15% to recognize the fresh and hardened properties. So I wasn't mentioning, I didn't want to go into the problems that we have with all these other materials that to some degree we can't control. We can't control what's happening to our aggregate, especially in Colorado. They're not allowing any more pits. But we have forced our industry to choose Type 1L cements for the betterment of the universe and, reduction of our carbon footprint. That's my question. The forcing the industry to go to a 10 to 15% reduction. Last night I got a IP25. I'm just reading up what an IP25 is. I thought it was a freaking beer. But this major change in the hydraulic material to get our water cement ratio, which is very important according to 211 and C94. That's right. I'm saying that is no longer percent error. Now that's because that's what your job is, percent error on materials. Now it's rolling the dice.
Yeah, so I think it's important that as we proceed, we got to think about three buckets to talk about. And here's how I'm going to simplify it. Because again, I'm a ready mix producer, so we like things simple. So 3 types of concrete. You've heard me say it before. There's BookCrete, there's LabCrete, and there's RealCrete. And while I started in the academic world, I tend to lean heavily into the RealCrete world. So when you talk about water cement ratio, my first thing I think of, honestly, is delivery tickets. So from a production standpoint, and I'm going to do simple math, and let's just use a water cement ratio of 0.45. I'm sorry, 0.5, so I can do the math easy. I want to produce a concrete to where the submittal was a 0.5. We'll work backwards to what that calculation is. All I know is that I produced it and I didn't put all the water in there that was supposed to go in there. It'll hold back water. We made adjustments at the batch plant, those kind of things. And there's a ticket that the driver has, e-ticket or paper. Again, not important right now. And on the bottom right-hand corner of that ticket, it says water allowed on job site, water to be added. And it's typically in gallons. And that tells somebody in the field in real time in the heat of battle how much water they can add to that truck and not exceed the submitted design water cement ratio in real time. And I don't think there's any disagreement on that process procedure at all. The challenge for us in the field, as we're looking at that, working all the way backwards through the submittal to the stuff that you want to talk about, John, I think that's how we have to kind of think. No matter how we're going forward, we always have to remember to work backwards from that answer of in the field where I've got to deliver it to a customer that has to make a real-time heat of battle decision. And so to me, no matter how the discussion proceeds and how we talk about it, it always has to end at that point.
Okay, that's fine.
Yeah. And so where I'm going is no matter how we slice it, I still have that thing I have to consider and manage.
I know. And that's the worst part of it. Like, this is happening in real time.
Yes.
And can I add one more thing to your 3 buckets? I have a 4th bucket. Is that okay? Whitney told me not to introduce the 4th bucket. She said, this is not the time, Jonathan. He's not going to like the 4th bucket.
Oh, go ahead.
I'm swinging for the fences.
I will submit it to the committee for consideration.
Seth on the committee because he hasn't said a dang thing. BookCrete, LabCrete, RealCrete. I think there's also StreetCrete. because I'm sorry to say, there are also you talk about everything from the production and the transportation side, right?
Yeah.
Then there's at the end of the shoot, to a certain degree, and I'll use Pareto's law here, 80% of the ready mix providers, once it leaves the chute, it's no longer my concrete. And that's when it becomes the street's concrete. Okay, so what I mean by StreetCrete is the people who use it, like the concrete pumpers, the contractors, the finishers, I mean, even the folks who are doing vertical construction, they do something to the concrete too to get it where they want it to. And when your guys aren't looking, or even to the guys who are looking, the truck drivers, they'll take the blah blah blah, and they'll kick up the water content. They ordered a 4-inch, but they want a 7-inch. Or hey, it's not pumpable. Well, if you need to make it pumpable, just add a little bit more water. So that's what I wanted to add, is the StreetCrete, which you don't intend to do, and goes on after you leave, or when your guys are looking the other way and they're looking directly at the concrete.
Yeah, and I would say that's a small bucket inside my big bucket of RealCrete. And the reason I say that is because even at StreetCrete, I still have the responsibility.
Totally. So
so to me, the responsibility aspect of it doesn't change.
But it's still a different bucket. Okay.
Yeah.
So I took your scenario and I put some math to it. And I know we can talk more about other things. And this is going back to, the thing about BookCrete, LabCrete, RealCrete, and StreetCrete is they're all connected. It is very unlike our current industry, where we have the academic industry and the commercial, the operational side. There's a huge disconnect. Book, Lab, Real, Street, there might be some fuzziness between the logic and some assumptions that we make as we go closer towards the RealCrete and StreetCrete, but there's still a connection. And while in the real or operational world, in the heat of the moment, we have to add water to get great concrete down the chute, because that is what you sell. There is always some type of sacrifice that we make the further we get away from, or the more we ignore the implications of the BookCrete and LabCrete. Did I say that correctly, or was that confusing?
No, I got you. I understand it.
Seth?
I understand what you're saying.
Okay. Go ahead, Rich.
No, I'm already on to the next thing, John. I'm looking at what you're talking about for water cement ratio.
And this is why I don't play Rich in chess, because he and I have had conversation. Rich is the reason I went and got a PE. I told Rich, I'm not going to get a PE, Rich. Aha! It's not going to happen. Rich took me out for dinner. I got dressed up real nice. Rich had just come back from doing like 2 miles of swimming in the local pool right after like 8 hours of ACI meetings. And we had this conversation that freaking, there are not many things in your life that change your character. I was not going to do the PE because I was afraid of it. Rich gave me the insight to build that drive. Anyway, I know you know where I'm going.
I do.
As it turns out, I have seen the implications of, hey, it's a 1-to-1, right? Use it just like we have the LabCrete data to show you 728, it works perfect.
All right. So before we talk about that, let me go back. Let me swing the pendulum to the other side about the real and StreetCrete. I'm going to temporarily grant you access to the fourth bucket, even though the committee hasn't approved it yet.
I'm good with that.
Okay. So you have temporary status. So you mentioned earlier about risk, and I think that's a critical thing for us not to discount. And let me give you an example. So let's go to 608 pounds per cubic yard of cement with a certain water content and a certain water cement ratio. And let's say I'm supposed to hit the 0.5. Let's forget about the prior conversation about water I withheld, okay? And let's just say I put all the water in that the mix design called for. And let's say it hit the target slump on the job site. But let's say I had 1% less cement in there than the design called for. So in your particular case,
6 pounds.
Right, 6 pounds. Or I added 1%. So I added 6 pounds. So I now have a range of cement from 602 to 614 with the same water content. I've varied the water cement ratio in that particular case, right?
Yes.
So all of a sudden now, so I have that variability that exists, that risk of hitting the target water cement ratio. Now, add in the flavor to our gumbo of, hey, wait a second, I held back 10 gallons at the plant, plus or minus 1%, and plus or minus on the water content as well. My point is, the water cement ratio discussion has to affect or has to account for my production variability before we even get to the variability that you're talking about with limestone content. So already the risk tolerance is greater on the RealCrete side and StreetCrete, again, temporary status, going backwards into the other two. So I'm just kind of bringing that point up, is that when I make concrete, I already have a variable range of water cement ratios that are both acceptable and allowed.
Yeah. I agree with you. What is that acceptable range?
Right now, again, so if you follow the book, it's plus or minus 1% on my cement, right? Because I'm allowed to weigh that up plus or minus with an accuracy of plus or minus 1%.
On your water cement ratio, that's accuracy of 0.01.
Now, but I also have an accuracy on water of plus or minus 1%.
So that's 3 pounds.
No. So now imagine I'm minus, but go to the extremes. I'm minus 1% on water. I'm sorry, minus 1% on cement, plus 1% on the water.
Right. 602.
So now I'm only highlighting it as to say that the precision starts off there, and so it's not as precise as you think on that side, just batching it. And all I'm doing is, John, I think I'm highlighting the fact that I'm going to exacerbate the problem you're going to allude to.
Right. And I'm so grateful you're going to do that, because I think what I heard you just say is this problem is a lot worse.
This problem is bigger. I'm not going to make an allegation. I haven't made a judgment as to I haven't made a judgment as to better or worse. I'm just saying this is what the measurements are at this point.
Yeah, but plus one or plus or minus 1% is nothing compared to 10.
Right.
Because that's
agreed.
That's what you're getting at. That's what Dr. John wants to get to.
Yeah.
And Rich makes me fight tooth and nail, no holds barred, man. One day, Seth, when you eventually come out to our facility, which I know is a huge, long drive, it's not like you're in Texas or something. I will show you the book of notes that I have from my discussion with Rich. I keep it in my library at the house. I was hoping it was here, but that was a no holds barred. It wasn't a nice conversation. One of the best conversations I've had in my life. And there's lessons to be had in that. And the recognition there is, I use the word cacophony. You know, when you're making and delivering concrete, it's not a quiet and delicate thing. You're not making a patisserie. You know, it is a freaking hodgepodge of shit going on, and there's failures, and there's gates opening up, and there's valves not closing, and somehow you still have to get great concrete down the chute. Is that a fair assessment, Rich?
Agreed.
What I have seen happen, and I admitted when we started this conversation, I don't make and deliver concrete anymore. It's been a long time. one of my closest friends, he got out of the industry 6 years ago. I called up my closest friend, Eric, and I said, hey, man, can you do me a favor? Are you in your kitchen? Are you in your house? He goes, yeah. I said, close your eyes. And he goes, what? I said, just do me a favor. Close your eyes. Take a deep breath. Let it out and recognize you are no longer making concrete. And you don't have to deal with that anymore. And by the way, he looks exactly like us. No hair and a beard, right? And he was like, holy shit, that's a great feeling. What I am saying is that it was risky enough when concrete was just a transportation business. I don't know how people are making concrete when reality is, Rich is talking about is not alive. There's a risk when it comes to making concrete per ASTM 484, but to me that risk is tolerable. Now, when we just look at, okay, there might be a swing between 10 and 15%, or 10 and 25%, because sometimes cement gets hung up in a silo, right, Rich?
That's correct.
And I'm sorry, but when I had intended to put 608 pounds in my concrete batch, and I assumed 10 psi per pound or per 10 psi per pound of cement at 28 days, and that's my KPI. And so I got 6,000 psi. That's what I was planning for, but it's actually 5,400. Okay, that's manageable, but I don't know. 551 or 517. If I accidentally add a little bit more water, oh wait, I'm not accidentally adding more water. I'm adding the same amount of water that I used to because I was told that this is a 1-to-1.
Yeah,
so,
but again, now your 301 pounds per cubic yard, I want you to reduce that by, let's call it 80 pounds. So, and the reason I say reduce it by 80 pounds is I'm going to hold back 10 gallons of water at the batch plant. We don't batch at 100% water in the truck. You always hold back 10, 15, 20 gallons. And all of a sudden now, what does that do for the concrete that goes out? Because I've got admixture in there, I've got gradation variations, I've got a variety of things in there. And now, what my point is, John, is that you've got a water cement. Again, I'm going to make it even worse. At the low end, I could be a 0.36, but when you go back to the full water content, your range, you were at what, 0.66? So your risk management, I could be producing concrete, depending on the limestone there. So let's leave it at 15% at the max, from a 0.36 to a 0.58. Is the risk of producing concrete on that day.
It's either starving or drowning.
Correct.
Whoa. That's, I mean, I hate quoting a Tom Cruise movie here, but that's risky business.
Yes.
I'm sorry, but I the only reason why I'm like hyperventilating here is I've seen the 0.66 version of that, the unintentional 0.66, and they're ripping and replacing bridges. Okay, they're small bridges. But for a mom and pop ready mix producer, a small bridge is career ending.
Yeah, so again, that there's a reason why at the bottom of the right-hand corner, I started with the, hey, water to be allowed, 15 gallons, 20 gallons, those kind of things, because that's the holdback at the batch plant. John, I've been doing this a very, very long time.
There's no questioning that, yeah.
I can count on one hand minus a couple of fingers the number of times I've actually had somebody say we put in 100% of the batch water at the batch plant. Wait a second. It's so rare.
Wait a second. You're right, but I can count on both hands and both toes when folks haven't done a calibration on their moisture probes, and even if they only put in 85% of the batch water, they're still putting in 120% of the design water.
Agreed. That could, that's. Yeah, moisture cook off. Did you are your probes working? All of those things.
There's a general concept here that I think we're missing because of the numbers. Like, you're right. More often than not, people are saying, trimming water out per cubic yard. I'm not arguing that. But they're also leaving water in the back of the truck. I'm not arguing what's going on in the computer.
Oh, God, yes. Oh, yeah. I mean, is it the first load of the day? Is it the third load? Is it the last load? I mean,
I find we do trims on cubic yards as a factor of safety to make sure that, hey, we'll get to the QC shack. We'll see what's coming out of the back of the truck. We'll listen. We'll look at the RPM gauge, and we'll add water to hopefully get in our window. But getting in your window, whatever that terminology is, I shared something on looking at the back of the truck and listening to an SCC concrete, and you can hear the shh. Then I had Kevin McDonald say, yeah, when we were at Semstone, that's how we judged our SCCs, by the sound of it. And I used to do that too, and we shouldn't. But it's the general concept that I'm going after. When you create the mix that you had intended, whether it was, hey, we got to the job site, we delivered them a certain batch, and we're allowing them to add 10, 15 gallons per whatever for the truck, for the yard, to get them up to what they ordered or what they wanted. So whatever you're doing, my argument is, now that you got them up to that actual water cement ratio that they needed to get them the water convenience, the water for hydration, my argument is the cement that you thought was going to do a certain job, right? Right? The fuel that was at a certain octane for your high performance vehicle or your low performance vehicle, what I'm arguing is it's not the right octane. And let me just finish. Right? Maybe that was the wrong analogy, but not the right octane can mean either you're not going fast enough, or you're not gaining enough strength, or you're destroying your engine. And in our case, plastic shrinkage cracking, excessive bleeding, dusting, there's a certain surface quality, aesthetics, or durability that we're losing here. So again, I'm not arguing that this is the method, this is the practice. It's once you get to what you transported and what they ordered, is it really doing the same thing, or are you hoping it's going to do the same thing?
Well, and now you're getting into the finer thing of the art versus the science, right? Now, and again, let me because I love coming on with Seth, because he allows us to deliver some brutal honesty, right? So, what happens after I have loaded that truck at the batch plant, and I go to the slump rack, loose term, and I have somebody rinsing the truck off for all the debris and material before they hit the road, and that hose just happens to rinse off the...
in there. It's not going in there. It's just cleaning out the hopper, man. What are you talking about?
And so I'll ask the rhetorical question of, have I impacted the water cement ratio? And if I have no idea to what degree. You have no idea to what degree. So, and these are those dirty little secrets that, again, Seth allows us to deliver with brutal honesty. Now, taking all that into account, right? So, risk, result, all of those kind of things. I think your point you're trying to make is an important one. Is at some point we are actually going to have to address the issue of we've been using water to cement. Some people calculate water to cementitious. Some people are calculating water to binder. We are now going to get to a point where we have to now redefine, and we have to educate designers who think when they specify a 0.43 water cement ratio for durability or structural purposes, they think that is, a certain amount of straight cement divided by, a certain amount of water divided by a certain amount of straight cement that is 100% pure cement, and has not considered that type 1 cement from 1950 is largely different than 2024 type 1L13. I think that's kind of where you're going.
If you look at the original title, it was, are we calculating water cementitious ratio, or water to binder ratio? Just like with these new compression machines, the automated ones that ramp up the hydraulic oil toward they shock load the system, so we get bigger strengths out of them. Are we changing the standard, or do we have to not let the automatic machines do that? Right?
Yeah, I think we're in a point where we're seeing more new definitions being created, or accurate ones, and I think that's going to help us. The problem is the people who are responsible for these definitions, right? You've got organizations, you've got codes, standards. You and I, we can list them. Some of them move, at a glacial pace of change. Some of them move at a geologic pace of change. And I've used that phrase before, and we don't have the luxury of waiting for that in the field. We really don't. I'll give you, a prime example is self-consolidating concrete. We were too stupid to know we couldn't do it before there was a standard that said it existed. When the 1L change you're talking about, John, people had to go back and look at their job specs that had forever listed ASTM-C type 150, ASTM-C 595, and ASTM-C 1157, because nobody really got past C150. They didn't realize there were two more commas and two more things specified.
Right.
All of a sudden, 2020 shows up. A variety of black swans hit simultaneously, and if I could add water, it was gray, it got hard, and it cracked. We took it, and we made things out of it. People are kind of like, what do you mean I've been using 1L? Yeah, you started using it a year ago. And because you said you needed concrete. And they were like, well, that's not in the spec. That's not, well, maybe it was, maybe, exactly. Nobody got past those things. So my point is that sometimes the codes, the standards, the specs may say it, maybe they don't, but a lot of people haven't read them. Again, to your point very early, John, about following the book. And Seth knows this all too well. When there are problems on job sites, what exists in writing exists. And if it ain't in writing, it does not exist and is a project deviation, and you had better hire a good consultant to defend you. Yep. So, again, all of these things are out there right now in real time. And John, I come back to one of your points you made, and I'll let you respond, is it's a risk issue now. It used to be a logistics issue. Now, every day, those are the decisions I make. I'm going to finish up this thing here in a little bit, and I'm going to go make risk decisions. And that's every day, whether it's at the trucks that go to the job site, whether it's with personnel, whether it's with financial things. That's really my job, is managing risk.
Yep.
And in concrete, I have to manage it every truck that goes out the door. Whether that is 1,000 yards today or 10,000 yards today, every truck carries risk. So I'll stop talking.
Well, I wanted to ask you a question. You said it's time to re-educate the designers.
Yeah.
Seth, did you notice he didn't say civil engineers?
I think they fall under that.
A civil engineer is not a designer.
Okay. Well, I think some of those designers, that's what they go to school for. They get civil engineering degrees. Right?
There was a very interesting shift that occurred about 15 years ago with mixed designs. When you would prepare a mixed design and you would submit it to the subcontractor, who would submit it to the general contractor, who would submit it to the engineer of record for the project. About 15 years ago, those mixed design submittals would come back approved, and there would be a big red stamp across them. Prior to Adobe PDF and having them electronic, they had those big red stamps they put in the ink pads, and whap, they would hit those things and they would say approved. Mm-hmm. And everybody would kind of pass them back down and go, please proceed, you've been approved. You know what the stamp says now, 15 years now going forward? the stamp says reviewed. That tells me a tremendous amount regarding a shift into the point John likes to make about designers. I'm using that as a broad term, versus liability, responsibility, and accountability. And this is a very big shift that has occurred, and it was a subtle one that nobody noticed until you bring it up, and you're like, hey, yeah, they're all just reviewed now.
Right.
And for those of us that are, again, have enough silver on our back and scars on our back, you're like, what happened and why did that occur? Here you go, big fat stamp. Bam.
I know, I was looking at it like, no way.
And so to me, that's that shift. And I think Seth was kind of making the point about designers and civil engineers and the people who do that. They review now. And ironically, the funny part is, to prove John's point, they go right to the book. What does the book say? Mm-hmm. Versus what does my experience tell me? So again, I'll stop talking.
And Seth was right. The word design engineer does encompass civil engineer. So Seth, you were right. I apologize for making that leap. My point of this whole discussion is we're making this game riskier. It was hard enough to make and deliver concrete. I do think we need to redefine something. And for the designers out there, and I tell you, some of the best concrete designers I've met, and I don't know why, but they haven't had civil engineering degrees. They've had degrees in English, right? Best concrete designer I ever made had an English degree from University of Denver, right? So I think it is a re-education, or not. You have to absorb that risk, and I'm just preaching.
No, I think you're 100% right regarding the re-education. The problem is that in our industry, from a technical standpoint, education always involves data. What does the data tell us? What does the data? Right. What does your curve say, John, versus my curve? What is your test result? And then we're going to scrutinize your test methods versus my test method. And then all of a sudden, 15 years are going to pass, and we've been having the argument inside of an alphabet committee that says your curve is different. And then all of a sudden, next year, I'm going to present a curve that's even more different than that. And we still haven't changed the definition.
Great.
Now, some of them are obvious. So let's talk about that a second. I'll give you a great side example. Is there a big difference between lightweight concrete and low density concrete? I would argue no. That is a redefinition of the terms, right? And we can talk about the academic weight versus mass and those kind of things. Mm-hmm. My point is, some of them are common sense and are very easy to kind of work our way through. I think when you're talking about water to cement ratio, water to cementitious ratio, water to binder ratio, I think that is one of those things where somebody is going to step forward and have to go, guys, this is how the definition should read.
Right.
I've been doing, again, working through so many of these committees and these alphabet groups that you never ask 6 people to write a letter.
Well,
you have one person write the letter, and then the other 5 help edit it.
Right.
And somebody somewhere is going to have to say, this is what our definitions should now be, and we're going to put them forward and have the conversation and discussion.
Can I suggest an alternative universe?
You bet.
You ready for this, Seth?
Yep.
Seth has to leave here in like 13 minutes. I'm watching the clock, Seth.
Oh, you're good.
Your redefinition universe, which can take 10 to 15 years, 10 to 15 months, somewhere in between, assumes that we are going to stay on this type 1L C595 journey. And the industry is going to continue to produce this and sell this. Is that the assumption?
No, not at all. Because you've already got cement companies that are producing a 1T. You have, when you go to the European model, the European model is at 1L25,
right?
2025. I think the train has left the station and it has momentum and will continue to progress. Right about the time that somebody says, oh, you know what? We're okay with 1L11. We've understand it. We know how to use it. Guys, we're at 1Ts and 1L18s.
1Ps, 25s is what I saw last night. So I'm agreeing with you on that. That your assumption is in this universe where we change the definitions, we continue down the C595 route and go further. You know, you remember back in the late 90s when we had that great cement shortage?
Yes.
When we started bringing in these cements from, where was it? Was it Nazareth, Pennsylvania? No, it was Asia.
Yeah, we had Asia. We had Chinese cements. You had Asian cements, Koreans, South Koreans. A variety of cements were being imported.
And man, did we like those cements, right? You got 28-day strength in 24 hours, right?
True.
Woo! What happened when we went back to those old Hoover Dam cements that Dick Burrows used to love?
Yeah, and again, the change in the cement, we've always accepted that, right? It changes over time.
Wait a second. When we went back to cements that were being produced in the U.S., our contractors said, we want those Asian cements that gave us 28-day strengths in 24 hours. And we no longer produce those Hoover Dam cements that Dick Burrows used to. If you don't know what Dick Burrows is, he was a gentleman who argued that we go back to the coarser grain cements that got us 28-day strengths in 28 days. Right? Not 3,500 PSI in 2 days or one day.
But the construction industry was also different then. There are two
I'm not
things.
Arguing that.
There are two things that are absolutely true on a construction site right now. One, they want to be as safe as possible, and two, they want to be as fast as possible. I laugh sometimes when I see these big initiatives that say, well, you know, we're going to do this by 2030 or 2040 or 2050. I can tell you right now, today, there are 3 priorities on the job sites of the concrete I'm supplying. Be safe, be fast, and be fast. Number 4,
that's what Rich sells.
And that's it. Nobody has 28 days to wait for strength, right? If we actually are benefit, and I'm going to say hypothetically, financially, from being faster with strength gain. I have contractors that tell me, hey, Rich, we pick you guys because we get 28-day strength in 7 days, and we multiply that by the 9 months of our project. You just saved us 6 weeks on our schedule.
In Hebrew, you say Zeh Bekeseb.
Yeah, and so, Seth, hey, if I told you for every project you have over 6 months long, I could save you 3 weeks of time, tell me what that translates into to bottom line money.
Big money.
Big money. Big money. And so all of a sudden now, that is what's driving us. And so when somebody says, hey, I need that strength, and faster, okay, we can do that. Do I care what the water cement ratios are at that point? Absolutely not. I need a target strength in 24, 48, or 72 hours or 7 days. And it's, as my 2 boys would say, let's go.
You just made my point, though.
I know.
I feel like, and Seth, I'm going to shut up after this. This is my closing point. As much as our industry is trying to push this carbon reduction, they never talk to people like Rich. No, went to MIT, they went to the admixture folks. They never went to the practical person. If they had just called people like Rich can say, you want carbon footprint reductions? Yeah, we can take care of that. It might cost you a little bit more, but we could totally do that, right? Or somebody might have said, yeah, we can start telling salesmen just to make sure that the formwork is ready before we release trucks. That's the fastest way to reduce carbon footprint on the job site. Make sure everybody's ready so you don't throw out any concrete. What I feel like is going to happen is we are going to push this gravy train, this freaking type 1L, type 1, is it IL? Is it 1L?
1L.
type 1L train with the IPs and the this and the that and the ITs until the lawsuits are so egregious. They're ad nauseum that people cannot afford to get insurance anymore. And I think there is going to be a resolving cry from the industry to go back to the C150 cements.
I disagree wholeheartedly. And here's why. For every anecdotal or lawsuit example that you can give me of somebody who was not successful with a 1L, okay, I can give you the identical anecdotal example of somebody who was. I can do the same thing with 1.2s. I could do the same thing when we had the 1.5s. I could do all of that. I've got large major construction companies across the country who are screaming that 1L and these things are causing problems. Well, how is it that the chuck and the truck that I also supply to can be entirely successful with 1L cement? Are you telling me that guy in that chuck in a truck with his one finisher and these kind of things can put a hard trowel finish in 108 degrees in Texas, but two of the largest concrete contractors in the U.S. can't? That doesn't make any sense.
They can't.
Particularly because they both came out of the plant on the same day using the same materials.
Yeah, but one person goes back to the job site after 7 days. The other one never sees the job site again.
Right. But again, to your point of StreetCrete, so again, I'm going to allow the temporary use of it. The StreetCrete guy, does he really know the difference between the two? All he knows is that one is working and the other guys are complaining about cracks. And so I am still of the mind of I've produced millions of cubic yards with this stuff, millions of cubic yards of this stuff. And I have a lot of people who are extremely successful doing it. Now, do I have people that have had issues? Absolutely. But I had a lot of people who had issues doing 1-2 cements. I had a lot of people who had issues using fly ash. I had a lot of people who couldn't understand the use of polycarboxylate mid-range admixtures.
Yeah.
These are not new problems for us.
I think so that is an argument that, hey, this is part of the business, that we're going to have problems and we just have to adapt to those problems. That is just, hey, your concrete's going to crack. That's why we started with the C.
So let me give you one more example because I know we're get close to time here. Have you ever, in your experience, ever had somebody want to tear out concrete because it made strength, but it was cured or finished incorrectly?
No, but they wanted you to put like a traffic membrane on it that was equal to or greater than the cost.
But the strength made strength, right? So, what happens when it doesn't make strength? What's the first question that always gets asked? How did you cure it? How did you treat the cylinders? How did you manage all that? Well, we've never had to do that before because it always made strength. Let me see if I understand you correctly. You're telling me you didn't have to follow the specification because you got the results you wanted. But when you don't get the results you wanted, your automatic answer is, well, we've never had to follow the specification before. Kind of a straw man argument to me. And all of a sudden now, when we change the materials, we change the characteristics, we change the properties, all of a sudden somebody winds up saying, well, we're not getting the result we wanted, even though we're still not following the spec.
Yeah, those people are jerks. I can't argue against those situations. What I'm trying to argue is those who are trying to do it the right way, whether if that's per the book or 85% of the book, they're having a tougher time because the glue is no longer the glue. If you take the manifold of issues that we've dealt with, now we're adding an unknown. And I would argue that something has to be done. And my third to last point is it's not type 1L. It is not even 11. It's not a limestone cement. I think we all have to agree and recognize that we're using a blended cement. So it is a Tom Cruise cocktail of not just cement, but other things to benefit the properties that we would expect, both fresh and hardened. Those are created by other things like calcium formate, other ingredients It's not just cement anymore.
Yeah, you're very clearly highlighting as we wrap up here that the importance of it's everything from discussing water cement, water binder, water to cementitious to the practical conversation. It's not, they are all connected. You cannot isolate one variable at all. You have to have a practical, in-depth conversation. So when I worked in politics for a little bit, one of the things I always said was you cannot solve a problem in a 3-minute podium speech. You are not going to solve a problem inside of a job site trailer around a folding table in a 1-hour meeting with 22 people in the room.
Yeah.
You need true practitioners to be in the room with the people who are making decisions and go, how do we link these variables together to create a good project to build something? They are not isolated things. They are all connected. In concrete, I always tell my guys, we cannot turn one knob without affecting 3 other things, which now means I'm turning 3 other knobs, which now means I'm affecting 7 things. It's risk, it's reward, and it's communication. And I think, John, that's ultimately where you were trying to drive this originally was we have got to start talking about this practically with practitioners, designers, and contractors to come up with solutions. And you cannot do that in the heat of battle when Seth sends me a note that says, hey guys, the bid is due tomorrow. Like, we didn't even know this project was bidding. Yeah, I need your numbers tomorrow. Oh, and by the way, I need mix designs. Today's Thursday. I need them tomorrow.
Nice going, Seth.
Yeah, blame the contractor.
Seth, if we didn't wrap up that way, good Lord.
Well, I don't.
What kind of engineers and designers are we?
So we're screwed. Is that the gist?
No, not at all. Not at all.
So it just sounds like we just keep doing what we're doing, but we need to recognize these new materials. Is that what you're getting at?
I think what sets Rich apart is that, and Rich, I'm sorry, I do have to tell about the great cement debacle of 2020 or 2019. Or I'm sorry, it was the great high range or mid-range water reducer caper. Rich has gone through, the first time I saw Rich speak was at an ultra high performance concrete convention in Dallas in 2006, 2005, something like that. And Rich was talking about 50% Class F fly ash mixes that were reported to get 8,500 PSI in 24 hours. And Rich is like, okay, come on, you guys, you're lying, right? Like, I know we want to do prescriptive to performance, but you guys are just doing 900 pounds of cement and replacing 50% of your sand with fly ash, and you're calling it 50% fly ash mix. There's something to that effect. Rich, the reason why Rich has been so successful in the industry is he is not afraid of problems. He loves running into the firefight and figuring out what the heck is going wrong. How do we solve it? There have been too many in the industry who took the face value of it's a one-to-one. Use it as you normally would. I remember when Rich called me up and said, hey man, mid-ranges are gone. Whatever we had and whatever we used with mid-range, you remember that conversation?
I do, yeah.
Overnight. It was like, I can't talk to you right now because I have to figure this out. And Rich normally drops everything, will take my call for 2-3 weeks. He was in that plant every day figuring out the problem. That's where I think Rich is coming from. And the unfortunate reality is other people in the industry have not done that. So they're going to continue to have a problem until they adapt.
Yeah, the other thing, John, I want to add to that, and I appreciate the kind comments. The other part about that is my customers who during that 2-week time period that you're alluding to, or even today, they don't care. They need the concrete to show up a truck fully loaded every 3 minutes to discharge into the hopper to be able to be placed and go. I use the duck on the water analogy. They don't care what happens below the surface. They need to see the ducks smooth and calmly coming to their job site every time that they've scheduled it. That's it. And that is what they care about.
I want to give you a hug.
Seth, tell me I'm wrong.
Not wrong.
I want to give you such a hug, Rich. Like, there's a reason you're losing more hair. I mean, holy moly, guacamole. Do you hear what we put them through? Shoot, Seth.
And so, Seth, to go back to the question you asked, you said you very, again, put it very bluntly, which I love about your podcast, is, are we screwed? And I don't think so at all. I think what has happened is I've seen this migration from 20 and the change and everything else. We have a lot of people that are trying to re-educate. We have a lot of people that are trying to complain. The third choice that they have is to communicate. Mm-hmm. And the most successful companies, contractors, producers, material suppliers, are focusing on that third choice. They're communicating directly, openly, and honestly. To John made a point earlier about, hey, can we get low carbon concrete? Absolutely, can do it every day. All you got to do is ask me, and I'll tell you how we get there. We now are seeing contractors. We are now seeing producers, engineers sitting down going, how do we solve this problem for real, and not in a 3-minute podium speech? They're actually taking the time to listen to each other. Those groups of people are now showing how successful they are. And I will tell you right now, the distance between success and failure is actually growing. It's not getting closer together because they're making that choice, the third choice, to communicate.
Can I ask one question real quick? And I promise I will shut up because I know you have seconds. Rich, could you have made a lower carbon concrete with the type 1-2 cements that was lower carbon than the type 1L cement?
Yeah, I can reduce the global. Let's use global warming potential just as kind of the new standard for measurement or metric for that.
Sure.
I could have lowered your GWP with a 1.2. I could have lowered your GWP with a 1. I can lower it with a 1.2. I can do it with a variety of things. Tell me tell me how you want the soup to taste. Don't tell me what to put in it.
Boom!
And I will make it taste how you want.
This is why he's top 5 with concrete rock stars in the world, Seth. Top 5. He's like top 3.
Yeah.
Oh.
All right. We got a lot of work to do.
I think
with people like Rich, it's going to be easier.
Yeah, but you guys got to recognize what's uphill from you too. It's got to come. It's got to come from the owner. So we're screaming at the supplier, but that's coming from somebody. It's not coming from us.
But Seth, if we scream together, we've got better strength and better results coming. And that's why I say the most successful projects that I'm part of have vendors, suppliers, subs, and generals all working together.
Yep. No, I think you hit it on that. What Dr. John was talking about, re-educating folks on this subject. So if you get the engineers and the designers on board, I think that'll go a long way because then they can talk to the owners and say, "Hey, this is the challenge. This is what we got to deal with." But there's most of the projects aren't like that. So
no, and again, we're trying to get these results, but we don't want to change anything.
Yep.
No.
All right. Well, fellas, that was a great one. Thank you. I appreciate it. And I know people got a plethora of knowledge today from these two.
Seth, thank you. Always, it's always a great time to be here. It's always an honor to be asked. Seth, keep spreading the gospel and keep doing what you do. You're clearly leading the industry in what you're doing. So thank you so much for having us.
Thank you. I appreciate that, especially from you, Rich. Thank you. All right, folks, until next time, let's keep it concrete.
Thanks for joining us for another episode of the Concrete Logic Podcast. If you got value from the show, here's how you can provide value back to support the show. Visit concretelogicpodcast.com and click the donate button to send value back. All dollar amounts are truly appreciated. And now, to close out the show, here's Mike Dunton.
Ring, ring, that alarm always sings. Couple hours before the sun comes up. Open up the side, put some diesel in the lights, and wait till the trucks roll up. Yeah, this ain't how most folks live their lives, dripping in sweat, working overtime. But while they're tying their ties for their 9 to 5s, we're out here changing these skylines with wood, iron, and mud. We work hard for a dollar, give thanks to the Lord above. Never make a man do something you can't prove. Hard work calls for a drink or two. Expect more, it's written in our blood. With wood, iron, and mud. From the swamps to the city, from the Lone Star heat to the woods of the Georgia pine. Good old boys and girls who ain't afraid of getting dirty for a clean time. And if you want to see the fire in a grown man's eyes beneath the hot summer sun, find the wild-eyed boys clocking days and nights, working hard to